Not yet. All right, so we are on lesson 6-3. Today's date is Thursday, December 5th. December 5th, 2019.
What?
We are evaluating radical expressions today. Quiet raise hand objective. Caroline got it first.
Use properties of exponents and higher powers of integers to evaluate radical expressions.
There it is. So we're using all the stuff that we've learned now to evaluate things. So in order to do these, it helps to know what your higher powers are. So we can get a ton of people to get XP. I'm going to try to level up as many people as possible. Each one of these is 50 XP. 2 to the power of 2. Quiet raised hand. Beverly. 4. Everyone write it down. Beverly got 50 XP. Thank you, at 0. You're going to be tapping away like crazy, I'm guessing. 2 to the power of 3. Quiet raised hand. Sam. There it is. Thank you. 2 to the power of 4 with a quiet raised hand. Colby.
16.
It is indeed 16. 2 to the power of 5 with a quiet raised hand. Chewy. You got this. Keep doubling. Keep doubling.
32.
There it is. 32. Thank you, Chewy.
I want to say 15.
Oh, you wanted to, okay. 2 to the power of 6. Quiet raised hand. India. 64. 2 to the power of 7. Bev Cheetos. 128. And that's kind of the cutoff for the homework assignment tonight. Just make sure you know that if you see 128, oh, that's 2 to the power of 7. I really care that you know how to go backwards. If you see 16, you're like, oh, that's 2 to the power of 4. Or, oh, that's 4 to the power of 2. All right. Again, 3 to the power of 2, quiet raised hand. Tons of people getting XP. Anna? 9, perfect. 3 to the power of 3. It's up on that wall. It's a perfect cube. Caroline? It is 27. And then we're getting bigger and bigger. 3 to the power of 4 now. India?
Is it 81?
It is indeed 81. And our last one is 3 to the power of 5. Beverly? 243. Again, if you see the number 243 lurking in the wild, know that is 3 to the power of 5. Again, we're going backwards. Now to the powers of, or 4 to the powers of 2, 3, and 4. 4 to the power of 2, quiet raised hand. Emily? 16. 4 to the power of 3. India?
64.
It is indeed 64. And that hard one, 4 to the power of 4. Beverly again? 256. Which is the same thing as 2 to the power of 8. 5 to the power of 2, Brian? It is indeed 25. And 5 to the power of 3, which is also on that wall up there. 5 to the power of 3. India?
It's 125.
125. There it is. All right, so make sure that we have those almost memorized. At least you have it in your notes so that you can refer back to it for the homework tonight. So let me talk about what happens when you have an integer to a fractional power. You can separate this into 2 parts. So if I have 8 to the power of 2/3, that's the same thing as 8 to the power of 1/3 times, or to the power of 2. I'm separating. I'm going backwards with one of our rules that states if I have a power to a power, that's the same thing as multiplying. 2 times a third is 2/3. We can all nod our heads. 2 times a third is 2/3. And now that I have 8 to the power of 1/3, that's really asking me what is the cube root of 8, and then once I do that, I will square my answer. And you can, again, if I'm doing cube roots, I should be able to look at my table or look at the wall if it's just cubes. The cube root of 8. What to the power of 3 is 8? And the correct answer, someone quiet raise your hand, let's get tons of XP today. What to the power of 3 is 8? Or what is the cube root of 8? What times what is 8? Beverly? 2. There it is. So that means that this cube root of 8 is 2, and I still have 2 to the power of 2. And then finally, 2 to the power of 2 is what? Quiet raised hand. Lots and lots of XP. I need to get you guys leveled up. Colby? 4. You will encounter probably at least 1 or 2 of these on the homework today. Question, Laura?
Can you go over that again?
Yes. So, no, I love when people say that because I know that you're not alone. So, 8 to the power of 1/3. And let me zoom in here so that everyone can see, everyone can follow along. 8 to the power of 2/3, I separated. Usually you want the fraction first, and then the whole number on the outside. That will help you do it. I mean, I could have done 8 squared first, and then taken the cube root of that. That is a little bit harder. It's easier if I have a fractional power, a unit fractional power on the inside, and then a square on the outside. And we'll be seeing on the next one, I'm going to do it 1/3 power first, and then to the power of 4. So on this one, I separated the powers, 2 and 1/3. And then 8 to the power 1/3 is the same thing as the cube root of 8 to the 1 power. This 1 is hidden now because it's in the radical form. Then I ask myself, what is the cube root of 8? And if I'm ever asking cube roots, I'm looking at that top row, looking at cubes. What has an area, or what has a volume of 8? And it's that cube that's right there, and it is a 2 by 2 by 2 cube, which means 2 times 2 times 2 is the cube root of, or is 8. So the cube root of 8 is 2. But I still have this 2 remaining, so I copy down this 2 again. 2 to the power of 2 is 4, which means 8 to the power of 2/3 is 4. We're going to do another one of these. Here we go. 27 to the power of 4/3. I'm going to first deal with a fraction. So I'm going to do 27 to the power of what? Quiet raised hand. Who's got this? Anna. 1/3. All of that to the power of?
4.
Perfect. That is our first step. You have the next step, Colby? Let's do it.
Cube root of 27 to the power of 4.
There it is. Cube root of 27, all of that to the power of 4. It's very, very similar to this last problem. With another quiet raised hand, what is the cube root of 27? India. 3. So this cube root of 27 is now 3. I still have to copy down this power of 4. So it's 3 to the power of 4. And then the final question is, what is 3 to the power of 4? Caroline. Say again?
81.
81, yes. And again, it's kind of cool to think about this. 27 to the power of 4/3 is 81. I can go from here to here. All right. That's just one basic building block in the hard problems that we're going to be doing today. Let's get a fist of 5 for just doing the integers to fractional powers. That last section. How are we doing on this section, fist of 5? I'm seeing 5s, lots of 5s. 3, and is it like 2, 3? 3, 4, 4. Okay, I know who to check in with next time. Okay, so here is our strategy. We're looking for numbers with factors that are these numbers. So if I see something that 8 times something will give me that number. So for example, I'm going to see 48 down here. I'm saying, okay, well 48 is not any of these numbers. But what are the factors of 48 where the factors are in this list that I've drawn in blue? So that's the strategy. I'm looking for factors that are in this list that we've created. If I ever see a weird number that's not in that list, it should be a factor of the number. So coming down here, I'm going to do the 5th root of negative 81 times the 5th root of square root of 3. And I need to simplify that, condense it down into just a number. And usually they do work out really nice. All right, so I'm going to do this one with you guys. 81. What is 81? How can I write that as something to a power? Quiet raised hand. What to what power is 81? I only see 2 hands. These people have participated a ton and ton. We'll give it to Lorea. There it is. 3 to the power of 4 is 81. To make sure it's negative 81, I'm going to do negative 3. Wait, is it to the power of 4? Yeah. Negative 3 to the power of 4. Perfect. Thank you, Lorea. And then I'm going to copy down the rest of the problem. This is still the 5th root of negative 3 to the power of 4 times the 5th root of 3. I only changed the fact that 81 is 3 to the power of 4. Hopefully I didn't lose anyone yet. If I have, this is the time where you can ask to slow down or repeat myself. Anna.
Where did the 4 come from?
Yes, so where did the 4 come from? If I look up at my table up above, I look for the number 81. I'm looking for 81, looking for 81, looking for 81. Ah, there it is. 81 is the same thing as 3 to the power of 4. Our first step should always be looking through our list to see if one of those numbers has been met. If not, it might be a factor. So 81 is 3 to the power of 4. 3 times 3 times 3 is 81. Or 9 times 9 is 81. All right. So from here, I'm going to convert from radical form to exponential form. You guys are helping me out. I need 2 volunteers. Negative 3 to the power of 4, and I'm taking the 5th root of that. Convert just this left one into exponential form. Who can do that for me? I see 1 hand. I see 2 hands. I see 3 hands. I see 3 hands out of a classroom of, what do we have today? We have 14. Now I have 4 hands. We'll give her to Beverly. There it is, to the power of 4/5. 4 over 5. Again, the right number is the one that goes on top. The left number, the index, is the one that goes on the bottom. This should be a review from our first lesson. So far, so good. Another volunteer. How do I rewrite the 5th root of 3 as a exponential problem? Or not exponential, as a, yeah, I think that's exponential, right? Yeah, exponential form. Colby. 3 to the power of 1 over 5, 1/5. No one is asking a question. I'm assuming that we're all okay by your silence. All right, next, whenever I have 2 of the same base, and I do in this case, normally we were playing with like x and x, they were the same base. This time I have 3 and 3, it's the same base. Whenever I multiply the same base, what do I do with these powers? What operation do I do? Anna. Add. Can you add 4/5 and 1/5 for us, please?
5/5.
So I still have this negative. A negative times a positive is a negative. So negative 3 to the power of 5/5, which is what you said. And you also simplified that for us, so thank you. And you said 5 over 5 is just 1, so it's just equal to negative 3. Question, Beverly. You do, yeah. So by multiplying these two, since it's the same base, you can kind of ignore the negative for now. The negative is only going to affect negative times a positive. It's the same base, just like we had before, x and x. And whenever I have the same base, I add the exponents. That's what it means.
Wait, don't you multiply the bases?
So let me give you a similar problem then. What if I had 3 to the power of 1 times 3 to the power of 2? What would you do?
Would it be 9 to the power of 3?
9 to the power of 3? Well, let's check. 3 to the power of 1 is 3, right? 3 to the power of 2 is 9. 3 times 9 is 27, which means 9 to the power of 3 should be 27 as well, right? 9 to the power of 3. Oh no, that doesn't work. Which means the shortcut is, even if I have the same base and it's just a number, don't touch it. Only add the exponents. It should be 3 to the power of 3, which is still 27.
So this is different than what we were doing?
It's the same thing as what we were doing. I'm just changing this from a variable to a number now.
Then why don't you multiply?
We
I
are
feel like what
multiplying.
we've been doing is we've like actually like multiplied the numbers or divided the numbers.
Yeah, so we have been when we didn't have any power. So before we were always dealing with 2 and 7. We were never dealing with 2 to the power of 3 before. Now that I've added exponents again into the mix, now we're using the rules of exponents, which states when I multiply 2 things with similar bases, I'm adding their exponents. Before I didn't have any exponents, so I didn't use rules of exponents because there were no exponents to use.
Oh,
So I can see if I can rewind to yesterday's notes and see if I can compare the two. Maybe that would help clear the confusion. Go computer. Algebra 2. We are on unit 6-2 was yesterday. So do we have any numbers in here? So
You
we
see how like 15 divided by 3 and you did it to 5?
yes, I did that because I had no exponents for the 15, no exponents on the 3. No exponents on the 27, so there are no rules of exponents to use. That's the difference.
So like the number is its own thing, and then the with the 3 like z square root or whatever that thing is.
Fourth root of z to the power 3, yeah.
Yeah, so that's its own thing, and then 15 is its own thing. It's not one thing. It's like 2 terms.
Yeah, I have 2 types, I guess. I have the constant term, and then I have the variable terms. In this case, I'm always going to give you constant terms, but now with fractional powers. Before, we didn't have any powers to deal with. If we did, you'd be using the same rules that I'm teaching you today. But we haven't gotten that hard yet. Now I'm throwing fractional powers just to those constants in with the mix. I have 3 to the power of some fractional power. Let's try another one of these. Example number 2. So negative 3 to the power of 5/4, I can't do anything with that. I'm just going to copy it down again. This is still going to be negative 3 to the power of 5/4. There's nothing much I can do there. But this fraction, 1/48, I somehow need to convert that into something easier. I look at 48 and I say, okay, well, where's 48? I come back up to my table that we've drawn up here, and I say, where's that number 48? 48, 48, 48, 48, 48, 48. I don't see it. If I don't see it, then I'm using this hint that I gave you guys, this strategy. Look for numbers with factors that are higher powers. So I say, okay, one of these numbers up here, stop, computer. One of these numbers up here must multiply into 48. 48 evenly divides by one of these numbers. Does anyone see a number up here that evenly divides by 48? Or evenly is a factor of 48? Beverly? Yeah, 8. 8 right here is a factor of 48. Let's try to see what happens when we do that. So if I did that, it's actually not going to work out because I hear Colby, he's saying the right answer. But if I did 8, it would be 6 times 8. But 6 is not one of the higher powers. So we're going to have to try again. Colby, can you say yours?
16.
16. If I do 16, I'll get 16 times 3. This one, it still looks like 3 is not going to work. But check this out. If I do 16 times 3, 16 is a higher power. I'll be able to convert that into something else. And 3 is being used right here. 3 will be able to be combined with this term. So I think this is probably the path that we should go. 6 times 8, I don't know what I'm going to do with that 6 eventually. There's not really much I can do unless I factor it again. So I'm going to do 16 times 3 because not only is 16 a higher power, just like 8 was, but 3 matches up with this term over here. So I'm rewriting this now. Instead of 1/48, it's 1/16 times 3. All of this still to the power of 5/4. Can you please not go off task? So from here, we're going to apply this exponent to both of these terms, to the 3 and to the 16. So that's my next step. I say this is going to be equal to, I still have that negative 3 up front. I still have negative 3 to the power of 5/4. And this is going to be multiplied by 1 all over, and this is 16. Actually, hold on. Let's not write down 16. What is 16? Quiet raised hand. 16 is a higher power. It's what to the power of what? Look at your table above. What is 16? What to the power of what? Quiet raised hand, Colby.
2 to the 4th.
2 to the power of 4. There it is. So we're going to say that's 2 to the power of 4. And then we have to apply this exponent of 5/4 to both of them. So it was to the power of 4, and I'm going to multiply that by 5/4. And I'm going to say, okay, that's times 3 to the power of 5/4. All right, so from there, I'm going to still rewrite this negative 3 to the power of 5/4. I can't do anything with him yet. Negative 3 to the power of 5/4. But now I can do something over here. I can say this is all going to be divided by this stuff. And we're going to simplify this a little bit. So can someone simplify what happens when I do 2 to the power of 4 to the power of 5/4? What happens with these powers? I see one hand. I only see one hand. When I do a power to the power, what operation am I doing? It's either adding, subtracting, multiplying, or dividing. It's one of those 4. Technically, it's one of the 3. We've never dealt with dividing ever. India? Yes, I'm going to multiply 4 times 5/4, and I get what?
We're going to get 20/4, which then simplifies to 5.
There it is. So 2 to the power of 5. Again, we multiplied 4 times 5/4. You can kind of cross cancel. You can kind of say, oh, just cancel out both of those. One is on the top, one is on the bottom. Just cancel out top and bottom, and I'm left with 2 to the power of 5. I can either cross cancel, or as India said, actually do the multiplication. 4/1. 4 times 5 is 20. 20 divided by 4 on the bottom is phi. That's where this 5 came from. All right. And again, I'm going to copy down that 3 to the power of 5 fourths times 3 to the power of 5 fourths. So I want you to think of these as two variables, or two types. I have the 3's and then I have the 2's. With the 3's, since I have the same base, is everything okay over there, gentlemen?
No, that's not that.
Since 3 is the same base, I'm now going to be dividing. When I divide something with the same base, what do I do? What operation do I do with their powers? I'm looking for quiet raised hands so you can get your XP. Only 2 people want to go in. Anna?
You subtract all the powers.
Yep. And then when I subtract, what am I left with?
5.
What is 5 over 4 minus 5 over 4?
That's 0.
0.
There's that 5 to the side, or do we just ignore them?
Which 5 to the side? This one?
Don't we have to add that to 5 fourths?
We can't add it because it's not the same base. Only same bases will work.
I see.
Yeah. So from here, that's basically going to cancel out all of those terms. All of that goes away, and I'm left with, I still have this negative sign. Negative, Sam? Negative 1 over 2 to the power of 5. And that's basically my answer. I can say, okay, well, 2 to the power of 5, I can't really do anything with that, so I come back up here. Well, what is 2 to the power of 5? Do I need to move you, gentlemen?
Sorry, that was me.
2 to the power of 5 is 32, so this is going to be equal to negative 1 over 32. There's my final answer. Question, Anna.
I'm confused on step number 2. How did we get 2 to the 4th? Yeah, that thing.
So how to get from here to here?
Yeah.
All right, so all I did to convert was, what is 16?
Can you just look at the chart?
16, yeah. The chart up above is the answer. What is 16? When I look at the chart, oh, that's 2 to the power of 4, so I change that to 2 to the power of 4. But then I also apply this 5 fourths to each of these. So it's 2 to the power of 4 to the 5 fourths, and 3 to the power of 5 fourths. So thank you for the question.
That's just confusing.
Can you please take your foot off the desk? Thank you. Ask a question. How can I help you?
I'll ask you after. Just like
Other questions on example number 2? I'm going to try to do as many different types of examples so that you can see all of the, as many types as possible. Should we feed off the part of your desk, please? Thank you. Example number 3. 72 to the power of 1/3 times the cube root of 1/9. All right, I look at the number 72, and again, every single time you see a number, you need to come up here to your list and say, where is 72? I'm looking through my list. I don't see 72. 72 is not a perfect higher power. Well, does something times something else in this list multiply to 72? Anna? 9 times 8. And not only, that's a really good option to choose because it's both here and here. Those are both higher power terms. So that's the perfect one to choose. 8 times 9. Again, you're trying to choose something from that list. So if I come down here, I'm going to rewrite this as, this is equal to 8 times 9, all of that to the power of 1/3. I just changed the 72 to 8 times 9. And now that's going to be multiplied by, let's get rid of this cube root. Let's turn that into an exponential problem. Something, exponential form, I should keep saying. This is 1 over 9 to the power of what? India. 1/3. There it is. Thank you. Ask me questions up to this point. Have I lost anyone yet? It's okay. You can be honest. You can be like, this is the confusing part.
I've been lost.
All right. So once again, whenever I have anything that's a cube root, I say the cube root of just x. That's always x to the power of 1/3. So if I see the cube root of 1/9, that's 1/9 to the power of 1/3. Whatever's on the inside to the power of 1/3. So that's the second part.
Where does the 8 times 9?
Let's talk about that first part again. So we needed to somehow turn the 72 into something that has a higher power. Every single time you see any of these numbers, the next step is looking for this number in that list. You always compare it to your list up above. What times what will give you 72? I'm looking through all of these blue numbers. What times what will be 72? And the best choice is these two numbers because they're both in the list. 8 times 9 is 72. Oscar.
Does anyone see my wallet? I lost it yesterday.
I'm sorry that you lost your wallet. If I see it, I will definitely let you know.
Oscar's wallet.
All right, so from here, I'm going to again compare each of these numbers to the list. What is 8? Quiet raised hand. What to what power is 8? Easy XP here. What to what power is 8? Beverly. Again, yes, it's 2 to the third, so I'm now rewriting this 8 as 2 to the power of 3. Times, what is 9? What to what power is 9? Quiet raised hand, Jaden. 3 to the 2, thank you. All of that is still to the power of 1/3. All right, this is going to be 1 over what to the power of 1/3? I'm changing this 9. What to what power is 9? Easy XP here. Come on, I want to get everyone in. Oscar, you got this. What to what power is 9?
Did you just put it up there?
I did not.
3 to the power 2.
Well, I mean, yeah, you're right.
Yeah.
Really. I thought you meant like in this spot. No, it is right there. Thank you. Thank you, Oscar. You can get your XP. And your card is in now. Okay, I've converted everything into a power. Now I'm going to start applying these rules of exponents. So here we go. Rules of exponents. This 1/3 is going to be applied to both of these two powers. I'm going to multiply both of these powers. So I'm going to need at least 3 volunteers for this next step. If I'm distributing this 1/3 power into each of these terms, I'm left with 2 to the power of what? Quiet raised hand. What is my new power? Colby.
1.
2 to the power of 1, exactly. It's 2 to the power of 3 over 3, which is the same thing as 2 to the power of 1. I'm going to keep it as long and drawn out as possible in terms of showing all of my work. I want to make sure all of my work here is shown so you can follow it later when you're comparing it for your homework. The next one, 3 to the power of what? Quiet raised hand. This is 3 to the power of what? I'm looking for the power here. Caroline. 2 over 3, there it is. Again, I'm multiplying 2 and then divided by 3. Perfect. And now this is going to be, all of this is going to be divided by, because I'm now leaving this as a fraction, 3 to the power of what? Quiet raised hand here. 3 to the power of what? That's Erie. 2/3, thank you. 2 over 3, because it was 2 and then divided by 3. This 1/3 was distributed into each of these. And 1 to the power of 1/3 is just 1. Question, Beverly. So whenever I'm multiplying by a fraction, where it's just on the denominator, that's the same thing as dividing, extending this line essentially. It's the same thing as if I said, what is 2 times 1/3? Well, that's the same thing as 2/3. I kind of move this fraction and just extend the line. Yeah, I'm sure you're not the only one with that question. All right, we're almost there. Question, Anna?
So we just dropped the 1 because 1 we don't remember, right?
I mean, if I wanted to, I could have written 1 right here times 1, because 1 was on the top.
Oh,
But adding 1 right there is kind of pointless since we have all this other stuff, and 1 times anything is anything. So I kind of just dropped it. Yeah, but that's a good question too. Other questions before I move on? All right. So now I'm looking for common bases. 2 doesn't have any other base, so I'm going to leave it. I come over here and say, I can't do anything, so this is still 2 to the power of 1, or just 2. But this has the same base. Whenever I divide something that has the same base, what do I do with the powers? Quiet raised hand here. What operation do I do with these powers? Jaden.
You subtract.
I subtract. What is 2/3 minus 2/3?
Nothing.
0.
Zero.
And anything to the power of 0, Jaden, is?
0.
Careful.
What?
Anything to the power of 0 is? So if I say, because when I do 3 to the power of 2/3 to 3 to the power of 2/3, you get 3 to the power of 0.
It's 1.
and that's equal to 1. There it is. So this is going to be 2 times 1, which is just 2. And there's our final answer.
That's what I thought. That's what I said. I thought it stays like as itself.
Okay. I don't know. When I take a step back and I look at these problems, they're kind of mind-blowing to me. Like, you look at all this really complex stuff, and you're like, oh, the answer's just 2.
Is there a shortcut? I know there's a shortcut to this.
To this one, I'm trying to make it as simple as possible for you
Are
already.
you sure there's not a shortcut?
If there was a shortcut and I knew it, I would definitely tell you. There might be a shortcut and I don't know it. So
Oh.
Looks like you got
I spent about half an hour doing these problems last night, making sure that I had good problems that were similar to concavity. That's the shortest way I know. I'm sorry. I'm trying to make it as easy as possible.
That you know, or you like? Can you like search it up and just teach us?
No, I googled everything. I did research. There's no faster way to do this. This is as simple as it gets.
You taught me how to do this.
Where did I learn this
So
first?
if you find a faster way, does that mean back like?
If I find a faster way, if you find a faster way, tell me. I will give you extra credit. If there's a legitimate faster way, because I cannot find it. All right, that's all I have for the notes. The best way to learn this now is by attempting and failing, attempting and getting it correct, attempting and failing this on the homework. Are there any questions before I let you loose? No.
No, I haven't gone.
Oh, you weren't here for lunch, right?
The restroom.
You can't, but Oscar can't. Oscar wasn't here. Sorry.
I can't go to the restroom.
Sorry. Oscar actually missed lunch.
No.
Give me a fist of 5 for the objective. My final fist of 5 for the day. Use properties of exponents and higher powers of integers to evaluate radical expressions. Give me a fist of 5 on all of this stuff. I'm seeing a 3. What is that, India? Is that
I'll give you like
4.5?
4.5.
Is that a 3.5?
I'll give
4,
you 3.5.
5,
4.
3, 4,
Solid 2.
2.5,
3.5.
2.5, 4. Nice. 3, 4.5.
3.5.
Is that 4?
That's 2.
That's 2.
These are just.
Okay, 4. And is it 2.5?
3.5.
Yeah, the best way that we're gonna do these is the best way we're gonna learn them is by doing them.